Welcome back, everybody, for another deep dive. This time we're tackling reinforcement learning.
Oh, yeah.
Always a fun one.
Always fun.
Specifically, how to make those AI agents,
Right.
learn faster and smarter
Yeah.
instead of, just spending eons wandering around their little virtual worlds.
It's a classic problem.
Yeah, like a lost puppy.
It really is a challenge that's kind of fascinated researchers for a long time.
Yeah.
How do you get an agent to explore,
Right.
learn, and adapt efficiently?
Especially in complex environments.
Especially in those complex environments, yeah.
And that's where this paper Successor Options comes in.
That's right.
It's like,
It's cool paper.
yeah, it's like handing our AI puppy a GPS.
Yeah.
But even cooler, because it's a GPS, they kind of build themselves.
That's the really cool part.
Just by interacting with the world.
It is really a great analogy.
Yeah.
This paper is all about helping AI agents, become more efficient learners by discovering these things called landmark states and figuring out how to get to them.
Okay, landmark states.
Yeah.
I'm intrigued. But before we get into that, can we rewind a little bit?
Yeah.
Because the paper keeps mentioning these things called options.
Right.
So what exactly are those?
Yeah.
And why are they important in this whole learning process?
So imagine you're teaching a dog a trick, right?
Okay.
Instead of breaking it down into like tiny little steps, like
Right.
lift your paw, move it forward, put it down,
Uh-huh.
you could teach it the whole shake hands routine at once.
Okay.
That's kind of what an option is. It's
Okay.
a sequence of actions, right? It's like a mini skill.
So it's like giving the AI agent a shortcut
Exactly.
so they can do more complex things without having to figure out every single step?
That's exactly right.
Okay.
That makes sense. Yeah, options can break down complex tasks into more manageable chunks,
Right.
which can really, really speed up the learning process.
That makes sense. But then how does the agent know which options to create?
Right. Because it can't just like randomly string actions together and hope for the best.
Well, exactly right. And that's where this
Absolutely.
really cool idea of successor representations comes in,
Right.
or SRs. These SRs essentially give the agent a map
Okay.
of how likely it is to reach any other state
Okay.
from its current position based on its past experiences.
So it's like looking into the future a little bit.
It is a little bit like looking into the future, yeah.
Based on what it's already done.
Right, exactly.
Yeah, okay. I like that the paper actually shows a visual of this figure too,
Yes.
showing an SR representing a state based on its future possibilities.
Right.
So it's kind of like peeking into the AI agent's mind
Uh-huh.
and seeing it think, okay, from here I could go left and maybe find a treat, or I could go right and explore a new area.
Yeah, that's a great way to put it. It's all about understanding the potential consequences of actions.
Okay.
And here's where it gets really cool.
Okay.
By analyzing these SRs,
Yeah.
we can identify states that are particularly well connected.
Okay.
Think of them as hubs or crossroads in a city.
Okay.
These are what the paper calls landmark states.
So landmark states are like strategic locations
Yes.
that give the agent access to a lot of different parts of the environment.
Quickly. Exactly.
Okay, so if they learn how to reach those landmarks,
Yeah.
then they can navigate much more efficiently.
Much more efficiently. It's like knowing the subway system of a city.
Right.
You can get around much faster once you know where those key transfer stations are.
Okay, that makes sense.
Right.
I'm starting to see how this all fits together.
Yeah.
But, learning to reach those landmarks,
Yeah.
that's got to be where things get tricky.
That's right.
So how do we incentivize the agent to
Yeah.
actually go to those places?
That's a great question. And this is where they introduce this idea of a pseudo-reward.
Pseudo-reward.
Yeah.
Okay.
That was a bit sneaky.
It is a little bit of a trick, but a really clever one.
Okay.
It leverages the information that's already present in the SRs. Remember, the SRs tell us the likelihood of reaching different states?
Right.
The pseudo-reward essentially encourages the agent to move towards states that have high SR values relative to the landmark that it's trying to reach.
So instead of getting an actual reward for reaching the landmark,
Right.
it's getting this virtual pat on the back for heading in the right direction.
Exactly.
Okay.
And the beauty of it is that the pseudo-reward arises naturally
Okay.
from the agent's understanding of the environment.
So no need for us to be constantly handing out treats?
That's right. No need for a human trainer.
Okay, that's pretty remarkable. But I'm already thinking, like, if these SRs are like maps,
Yeah.
building a complete map of a complex environment, that's going to take forever.
You're right. And that brings us to another clever idea in this paper.
Okay.
Incremental successor options.
Okay.
So imagine, instead of trying to create a perfect map of the whole city up front,
Right.
you start by mapping your neighborhood. Then You map your district, and then you slowly expand your map as you explore.
Ah, so it's a much more practical approach,
Exactly.
step by step.
Yeah.
And Figure 6 actually shows how this plays out visually,
Right.
with the agent's explored area kind of gradually growing over time.
That's right.
Okay. So incremental successor options really let the agent make the most of limited exploration time,
Right.
which is often the case in real-world scenarios.
Yeah, and especially with, more complex environments.
Big
That would
development.
take a really long time to explore.
Yeah.
Okay, so this is all incredibly fascinating,
Good.
but I'm already like dying to know how these ideas play out when we
Right.
move beyond those simple grid worlds that we always see in these papers
Right.
and into the wild west of the real world,
Yeah.
where things are messy and continuous.
Yeah, where things are not so neat and tidy.
Yeah, think robots moving smoothly through space,
Yeah,
not hopping from one grid square to another.
exactly.
So how do we tackle that?
That's where things get even more interesting.
Right.
And that's where we'll step into the world of deep successor options
Ooh.
when we come back.
All right, I'm ready for it. Welcome back.
All right.
So we're about to step into the world of deep successor options,
Okay.
where we're combining these landmark ideas with the power of deep learning to tackle those really complex continuous environments.
Okay, my brain is ready.
Good.
We left off talking about a robotic arm.
Right.
So let's get into the nitty-gritty of how do you actually apply successor options when you're not dealing with these, neat little grids.
Right.
And instead you have like smooth movements,
Right.
intricate tasks.
Yeah, so the core idea is the same.
Okay.
Find those landmark states and learn how to get to them.
Okay.
But now, instead of these neat little grids, we're dealing with like an explosion of possible states and actions.
Yes, right.
Imagine trying to store all that information in like a giant lookup table.
Right.
It would be a nightmare.
Yeah, my computer would probably melt
Yeah.
just trying to load that table.
Okay. So that's where these deep neural networks come in.
Okay.
These powerful algorithms that are really good at finding patterns and making sense of complex data.
Okay.
So instead of storing these massive SR tables,
Right.
we can train a neural network to approximate them.
Gotcha.
The paper calls these learned representations successor features, or SFs.
SFs. I
Yeah.
like it.
Yeah.
It's like the neural network is creating this compressed, efficient version of those giant maps we were talking about.
That's a great way to put it.
Okay.
And here's the really amazing part.
Yeah.
Even though we're using these like neural network approximations,
Right.
the principle of clustering still works.
Okay.
We can still group similar states together and find those landmark states.
So even with all this added complexity,
Yeah,
those landmarks still pop out.
they do. And the paper has a really great visual of this
Oh.
in Figure 8.
Okay.
They tested this on a robotic arm task,
Okay.
the fetch-reach environment, where the arm has to learn to manipulate objects in 3D space.
That's way more complex than navigating a grid.
way more complex.
Okay.
And when they clustered these successor features,
Okay.
they got a really natural partitioning of the state space.
Okay.
The clusters clearly corresponded to different regions where the arm could reach.
So it's like the neural network learned to map out the arm's workspace
Yeah.
and highlight the areas where it could, effectively control.
Exactly. It's really, really cool.
This is blowing my mind a little bit.
Yeah.
We're teaching AI to learn like this just by interacting with the world.
That's the beauty of it.
Yeah, and figuring things out on its own.
But remember, we still need a way to guide its exploration.
Right, those pseudo-rewards.
Right.
So do those still work?
They do. It's the same principle, just adapted to work with the successor features.
Okay.
So instead of calculating the pseudo-reward based on the difference in SR values between states,
Right.
we can use the difference in SF values.
So it's still being motivated to move towards states that have those higher values relative to the landmark.
Exactly. The underlying logic remains the same.
Okay.
We're leveraging the structure of the environment,
Right.
captured by those successor features,
Right.
to guide the agent's exploration.
Okay, that makes sense.
Yeah.
But then the paper also mentions using something called proximal policy optimization,
Right.
or PPO,
Yeah.
to actually learn these option policies. So
Yeah.
can you break that down for me?
Yeah, so PPO is a really, really powerful algorithm
Okay.
for training agents in these complex, continuous environments.
Okay.
It's known for being very stable and efficient.
So it's like the training method
Uh-huh.
that helps the agent figure out how to best use those options that it's discovered.
Exactly. It's like the engine that drives the learning process.
Okay.
And combining deep successor options with PPO
Okay.
seems like a really good recipe for success.
So we've got this powerful way to discover options, and then we have this very robust way to train the agent to actually use them effectively.
That's right.
This is starting to feel like a real game changer for AI.
It really is. And remember, this whole framework is based on the agent learning without any external rewards.
Right.
It's discovering these skills just by exploring and making sense of its surroundings,
Right.
which makes it incredibly adaptable.
Yeah, that's a key point worth repeating.
Yeah.
It's like it's intrinsically motivated to learn about its world, not just to chase some external reward.
Exactly.
Okay. But I'm sure there are limitations
Of course.
and things that could be improved.
Yeah, the paper highlights some areas for future research, like
Okay.
exploring more robust ways to define when an option should end,
Okay.
investigating how to further improve the accuracy of those successor features,
Right.
especially in these really high-dimensional spaces.
So we've built a really fantastic foundation,
Yeah,
but there's always room for improvement.
always room for improvement.
Okay. Okay.
That. Yeah, and the authors also suggest exploring ways to combine those external rewards
Okay.
with these intrinsic pseudo-rewards,
Right.
which could be really interesting for tasks where we want to guide the agent towards some specific goals,
Right.
but we still want to encourage exploration.
Yeah. So it's kind of like giving it both a compass and a map.
Exactly.
So it can, explore, but also reach a specific destination.
That's right.
Okay. But before we get into all of that,
Yeah.
I'm curious how successor options compare to some other techniques that researchers have explored
Right.
for discovering these, useful options, because there have to be other ways.
Yeah, there's been a lot of work in this area.
Okay.
Some approaches focus on identifying what are called bottleneck states.
Bottleneck states.
Yeah. Imagine like narrow passages or bridges
Okay.
that provide like the only way to get from one area to another.
Oh, so kind of like landmark states?
They are similar in some ways,
Right.
but successor options have a different focus.
Okay.
They're not just looking for any connection point. They're looking for states that are representative of well-connected regions.
So it's not just about being a bridge.
Right.
It's about being a central hub
Mm.
within a cluster of similar states.
Exactly. It's a more nuanced approach.
Okay.
And by focusing on these landmark states,
Okay.
successor options can create options that are more robust and adaptable.
Okay. But why is that better?
Well, think about it this way. A bottleneck might just be a narrow passage
Right.
that leads from one area to another.
Right?
It doesn't tell you much about the areas themselves.
Right.
A landmark, on the other hand, is like a landmark in a city.
Okay.
It tells you something about the character of the surrounding area.
It's like the difference between like a random alleyway
Right.
and a famous square in a city.
Exactly.
Oh.
One is just a passage.
Right.
The other is a destination in itself.
Okay.
So by focusing on landmarks,
Yeah.
successor options create options that are more meaningful and informative.
Gotcha.
They help the agent understand the structure of the environment at a deeper level.
That makes a lot of sense. But what about techniques that don't explicitly try to identify specific states?
Right. So there are approaches like option critic
Option critic.
that attempt to learn options end to end
End to end.
without relying on these predefined subgoals.
That sounds really ambitious.
It is, but it comes with its own set of challenges.
Okay.
End-to-end approaches can be harder to train,
Right.
and they might not generalize as well to new tasks.
So there's kind of a trade-off there
Yeah, there's a trade-off.
between flexibility and maybe ease of learning.
Right, exactly.
Okay.
So successor options strike a nice balance
Okay.
by leveraging the structure of the environment
Okay.
to guide option discovery,
Right.
which makes them easier to train and more adaptable to new situations.
Okay. Well, I'm really impressed by
Yeah.
the ingenuity of this framework.
Yeah.
And the potential.
Yeah, it's a really significant step, I think, in
Yeah.
creating agents that can learn so efficiently and effectively.
And in these complex environments, which is really exciting.
And it's a testament to the power of, combining these clever algorithms
Yeah.
with deep learning.
It is pretty amazing what we can do with AI these days.
It really is. But, as with any cutting-edge research, there are always open questions and exciting avenues for future exploration.
Right. And the authors lay out a really nice roadmap in this paper
They do.
for where this research could go.
Yeah, highlighting some key areas where successor options can be further enhanced
Okay.
and applied to even more challenging problems.
Yeah.
It's a really exciting time to be following this field.
Absolutely.
I can't wait to see what breakthroughs lie ahead.
I think we're going to see some really amazing applications of these ideas
Yeah.
in the coming years.
In the years to come, for sure.
But before we get carried away with all the possibilities for the future, I think it's time to maybe bring it back down to earth a little bit
Okay.
and explore some potential real-world applications
Yeah,
of
Bob.
this research.
That's a great question, and one that we'll tackle head-on in the final part of our deep dive.
All right.
From robotics to healthcare to personalized education to even city planning, the possibilities are really vast.
Stay tuned. Welcome back to the deep dive. We've spent the last two parts really getting into the technical weeds of successor options.
Yeah, we have.
Exploring how AI agents can learn efficiently
Right.
by discovering these cool landmark states
Uh-huh.
and figuring out how to reach them.
Yeah, it's been quite a journey.
It has.
We've seen how these ideas work in simple grid worlds, how they scale up to complex robotic tasks with deep learning,
Right.
and how they compare to other approaches in the field.
My brain is definitely doing a happy dance right now,
Good.
but I think it's time to step out of the lab a little bit
Okay.
and into the real world.
Yeah.
What are the potential applications of this research?
Yeah, how could successor options actually impact our lives?
Yeah.
That's the question that always gets me excited.
Yeah.
This isn't just theoretical stuff. It has the potential to revolutionize so many different fields.
Okay, give me some examples.
Sure.
What kind of real-world problems are we talking about?
Let's start with something we've already touched on. Robotics.
Okay.
Imagine robots that can learn complex tasks much faster,
Okay.
adapting to new environments and challenges with ease.
So it's like having a robot that's not just programmed to do one thing,
Right.
but can actually learn and improve over time.
Exactly.
That opens up so many possibilities.
It really does.
Yeah.
This could lead to breakthroughs in manufacturing where robots could handle more intricate assembly tasks.
Okay.
Or in healthcare where robots could assist surgeons with greater precision.
Okay.
We could even see robots playing a larger role in space exploration,
Wow.
navigating uncharted territory and adapting to unexpected situations.
It's like those sci-fi movies where robots are doing all sorts of amazing things
Right.
are starting to feel a little less fictional.
A little less fictional.
Yeah.
And it's not just about robots.
Oh.
This research could have a major impact on personalized education.
Okay.
Imagine AI tutors that can adapt to each student's individual learning style and pace.
That would be a game changer.
It would be huge.
Instead of this one-size-fits-all approach,
Right.
we could have systems that truly understand how each student learns best
Exactly.
and create a personalized learning path for them.
That's the idea.
Yeah.
Successor options could be the key to identifying those crucial landmark concepts within a subject.
Okay.
Those key ideas that unlock a deeper understanding.
Right.
The AI tutor could then guide students towards those insights in a way that maximizes their learning.
I'm already thinking about how this could transform education.
Yeah.
But what about healthcare?
Yeah.
I'm always fascinated by how AI is being used in medicine.
This is an area with tremendous potential.
Yeah.
Think about AI-powered diagnostic tools that can analyze vast amounts of medical data,
Okay.
identifying subtle patterns that human doctors might miss.
It's like giving doctors a superpowered magnifying glass.
That's a great way to put it.
Yeah, helping them see things they couldn't see before.
Exactly. And successor options could be crucial for training these systems.
Okay.
They could help the AI learn to navigate through the complex landscape of medical data,
Right.
identifying those key pieces of information that are most relevant for diagnosis.
So earlier and more accurate diagnoses,
Exactly.
which could ultimately save lives.
It's really powerful stuff.
This is incredible. It seems like successor options could have a positive impact on so many aspects of our lives.
Yeah.
But this all sounds pretty high-tech.
Mm-hmm.
Are there any applications that are a bit more dot every day?
Absolutely.
Okay.
Think about those recommendation systems we all use on a daily basis.
Okay.
You know, the ones that suggest movies on Netflix or music on Spotify?
Oh, yeah. Those algorithms that think they know my taste better than I do,
Right, exactly.
but sometimes they get it right.
Sometimes they do.
Yeah.
That's because they're constantly learning and improving.
Right.
And successor options could make those systems even smarter. Okay.
They could help the algorithms understand your preferences at a deeper level,
Okay.
predicting what you'll enjoy even better.
So finally, algorithms that truly understand my eclectic taste in music.
Yeah.
I'm all for that.
And here's a thought that's particularly fascinating to me.
Mm-hmm.
What if we could apply these principles beyond AI
Okay.
to human learning itself?
Wait, you're saying we could learn something from how AI learns?
That's the idea.
That's mind-blowing.
It is pretty mind-blowing.
Yeah.
What if we could identify those landmark concepts in different fields of knowledge?
Yeah.
Those key ideas that unlock a deeper understanding.
Right.
We could then create learning paths that guide students towards those crucial
Oh,
insights,
okay.
making education far more efficient and engaging.
It's like creating a mental map of knowledge
Uh-huh.
and highlighting the most important destinations for learners.
Exactly.
I love that idea.
And it's not just about individual learning.
Oh.
Think about urban planning,
Okay.
designing cities that are more efficient and enjoyable to live in.
Right.
What if we could use successor options to identify those key locations and services that make a city truly thrive?
So instead of just building more roads and buildings,
Right.
we could actually design cities that are optimized for human well-being
Yeah,
and social connection.
exactly. It's about thinking smarter, not just bigger.
I like that.
And
Well-
successor options could provide us with the tools to do just that.
Okay, this has been an incredible deep dive. We've gone from, the technical intricacies of AI algorithms to exploring, their potential to reshape education, healthcare, even the very cities we live in.
It's a perfect example of how fundamental research can have far-reaching implications,
Yeah.
pushing the boundaries of what's possible
Right.
and inspiring us to think differently about the world.
And remember, this is just the beginning.
Yeah, this is just the start.
The research behind successor options is still evolving,
Mm-hmm.
and I have a feeling we'll be hearing a lot more about it in the years to come. I agree. It's a really exciting time to be following this field,
Absolutely.
and I can't wait to see what breakthroughs lie ahead.
And to all you listeners out there,
Yeah.
keep that curiosity burning. Who knows? Maybe you'll be the one to apply these ideas to solve some of the world's biggest challenges.
That would be great.
Until next time, keep on learning
And keep diving deep.
and exploring.